ഇപ്പൊ എന്താ ഒരു കാണാൻ പോവാ നല്ല
Good evening, everyone. Shall we start the session?
Yes.
Yeah, good evening.
Yes. Today topic is extremely relevant for modern engineers, especially. Yes, the new topic, yes, it's relevant to the present engineers focusing topic, that is zero waste manufacturing. As future professionals, you will be entering industries that are rapidly transforming towards sustainability, automations, and resource efficiency. So, these sessions will help you understand the key principles, methods, techniques, and some of the real world practices used to reduce the waste in manufacturing systems. I encourage you to stay engaged and think about how these concepts connect to your engineering discipline. So let's begin our journey towards building smarter, cleaner, and more sustainable industries. Yes. What is zero waste manufacturing? It is an approach where the goal is to ensure that no material, resources, or energy used in the production process end up as waste. So instead, everything is either reduced, reused, recycled, and recovered. So, in terms, a zero waste management tries to design waste out of the process. So, this means planning production in such a way that every input become a useful output, either the same process or for another one. So why this concept is most important for the modern engineering industries? Because today companies are under pressures from environment regulations, especially raising material cost and sustainability goals. So the waste is not just on environmental issues, it is a financial loss also. So every piece of scrap, defective items, or unused energy represent money thrown away. So the engineers play a crucial role here by designing these systems, machines, the process that maximize waste from the very beginning. So another key important point here is zero waste practice is improve the efficiency, product quality, and mainly focused on brand reputation. So the modern industries accept engineers to be environmentally responsible innovators who can develop cleaner technologies and smarter production methods. So, as a future engineers, your role goes beyond the technical skills. You will also help build factories and products that are sustainable, efficient, and competitive. So, the zero waste manufacturing is one of the most powerful as well as the way to achieve this. Need for zero waste manufacturing. Now let's understand why zero waste manufacturing has become a necessary, not just an option. So first, industries today are generating huge amount of waste from metal scrap and chemicals to packaging and rejected parts, etc. So the managing this waste is becoming increasingly difficult and expensive. As a future engineers, you will be responsible for designing process that reduce this burden. Second, all this waste contribute directly to environmental pollution. Landfill or overflowing, especially the water bodies are contaminated by industries discharge, and the air pollution from manufacturing process is at an all-time high. So the zero waste systems help the industries to reduce their ecological footprint. Then third, we are facing the resource scarcity also. So the natural resources like metal, minerals, and fossil fuels are finite, right? So when industries waste materials, they are essentially wasting resources that future generations may struggle to access these resources. So the zero waste methods ensure better utilization and conservation these resources. Then finally, the production cost also rising. So the raw material are getting costlier and waste disposal charges are increasing. So by recycling the waste, the industries can possible to save the money as well as improve the efficiency as well as stay competitive. These three benefits are involved. So when we talk about zero waste manufacturing, we are not just talking about the sustainability. We are talking about smarter, more efficient engineering. So that's why your role as engineer is crucial, yes, in driving this transformation. The next, let's look at the key principles that makes zero waste manufacturing possible. These principles act like the backbone of any sustainable production systems. First, resource efficiency. This means using material, energy, water, and manpower in the most optimal way. So, as engineers, your goal is to design the process where every input is used fully. So, with minimal leftover. So, the resource efficiency directly reduce the waste and lower cost. Second, closed loop systems. Closed loop systems ensure that the materials never leave the production cycle as waste. So instead, whatever is produced on output, even scrap or by products, is fed back into the system or reused elsewhere. So think out of it as recycling built into the manufacturing process itself.
मुफ्त
Then
किती
third,
बदल
lean manufacturing. Lean manufacturing focused on removing all forms of waste, especially whether it's material waste, time waste, overproduction, waiting timing, unnecessary movements. So the lean principle help the companies improve productivity while reducing the resource consumption. So this is one of the most important framework the engineers use in industry. Then finally, product redesign. Sometimes when happen because the product itself it's not designed for efficient manufacturing. By redesigning product to be modular, simpler, or easier to assemble or disassemble. So the companies can reduce the waste uh, dramatically. This is where the engineering creativity it's playing a major role here. So together these principles help the industries move towards a cleaner, more cost effective and future ready manufacturing model also. Then zero waste methods in engineering. Now discuss some practical method engineers use to achieve zero waste manufacturing. These are the techniques you will actually work within the industry. So first one is material substitution. Sometimes the waste comes from using materials that are different to recycle or it's prone to defects. So by switching to eco-friendly, the recyclable or more durable materials, we can reduce the waste right from the design stage. So for example, uh, replacing certain plastic with biodegradable yes polymers, or using alloys that have better recovery rate, right? Then process optimization. A lot of waste, the maximum of waste is generated simply because the process are not efficient. So through the optimization, such as improving machines accuracy, then reducing the recycle timing, then minimizing scrap during the cutting, so the engineers can significantly cut down the waste. So this is one of the core responsibility of industrial and mechanical engineers in manufacturing plant. Then energy efficient technologies. Energy waste is also a form of industrial waste. So using energy efficient motors, yes, the heating systems and renewable energy sources, it's helped the industries reduce the carbon footprint as well as cost also. So the technologies like heat recovering systems ensure that residual heat is not wasted but it's reused. Then digital monitoring, like IoT sensor. So the modern factories use the IoT sensor, Internet of Things, right? You know that IoT. So IoT sensor to continuously monitor the machines, the material flow and energy use. I mean energy usage. These sensor help to detect the deviations very earlier. So like excessive vibrations, unnecessary idle time, drops in efficiency likewise, so which allows immediate corrective actions. This prevent that defects, reduce the down system and minimize the waste also. So all these methods, yes, the four, work together to create the smarter and efficiency, okay, in the industries. Then next, let's explore on exciting concept in sustainable engineering called industrial symbiosis. That is, the industrial symbiosis means that waste from one industry becomes a useful input for others. Instead of sending byproduct to landfill, industries exchange ecosystems. It's similar to how the natural ecosystems work, then nothing is wasted. So everything is reused by another organism. So here are some common example I'm just to giving you. Yes, one is heat recovery. So the industries that generate excess heat, such a power plant or steel mills, can transfer that heat to the nearby industries for dyeing industries or heating industries or steam generations. So this reduces energy consumption for both sides. Then fly ash usage also. You know that thermal power plant produce the fly ash as a major waste product. But instead of dumping it, cement and brick manufacturing industries use the fly ash as a raw material. So this is not only reduce the waste but also lower the demand for natural resources like sand and clay, right? And then another thing is slang recycling. The steel industries produce lot of slag, so which can be reused in the road constructions, the cement productions, and sometimes that even in fertilizers. So this create value for something that would otherwise be discarded. So the industry's symbiosis, yes, is a perfect example of how the engineering, collaborations, and sustainability come together to reduce the waste and create a circular economy. So, as a future engineers, the understanding these inter-industry connections will help you to design smarter and greener industry systems. Then lean manufacturing and waste minimization. Lean manufacturing is built on the idea of eliminating anything that does not add value to the final product. In Japanese, these non-value adding activities are called muda. Yes, which simply means waste. So the seven type of waste, we can simply say is Muda formula. So the lean identify these seven major forms of waste in production systems. That is overproductions. It's making more than needed. So automatically it's lead from waste. Another thing is waiting. The ideal time due to delay or lack of material. Then transportation, unnecessary movement of materials. So the damage will be lead. Automatically the wastage will come. Then over processing, doing more than required, work than required. Then inventory, excess raw material or finished goods. Then motion, unnecessary movement of people. Then defects also, item that fail quality checks, yes, and lead to reworks. So as a engineers, your job is to design the system that eliminate these wastes as much as possible. Then value stream mapping, we can simply call it as VSM. That is, this is the visual tool used to map out every step in the production process, from raw material to final goods. So with VSM, you can identify where delays, bottlenecks, or unnecessary steps exist. So it's help you clearly see where wastage is happening and how to improve the flow. Then continuous improvement. In that concept, we can call it as kaizen. That is also, it's a Japanese word. It's a kaizen means it's continuous improvement. So the kaizen focused on making small constant improvement over time instead of big expensive changes. The kaizen discourage the team to keeping looking for minor adjustment that reduce the waste and improve efficiency. So it built a culture where every engineers, operators, can staff members actively work towards better process. So together these lean principle help the industries to reduce the material waste, save time, improve quality, and create more reliable manufacturing systems. Then waste reduction technologies. That some modern technologies that helps industry significantly to reduce the wastage. These technologies are transforming how the engineers design, produce, and package the materials, I mean products. First one is additive manufacturing, that is 3D printing. The traditional manufacturing is subtractive. We cut away material which create scrap. But additive manufacturing does the opposite. Yes, which we have follow in the tradition. It built the object layer by layer. So which only the amount of material required, this tragically, yes, reduce the material waste. So it's also great for prototyping, customize the part, and complex shaping that cannot be made using conventional methods. Then CNC precision machining, that is CNC machines offer extremely high accuracy and repeatability. So because the machines is precious, there is less scrap, fewer defects, and reduce the reworks also. So the engineers can optimize tool path, speed, and its feed rate to further minimize the waste and energy usage. Then recycling packaging. A large portion of industrial wastage comes not from product but from the packaging materials. So the using biodegradable and reusable or recycling package reduce the landfill wastage and lower environmental impact. So the many companies now design packaging with minimal material while still ensuring safety. Then green chemistry. Green chemistry focused on designing chemical process and product that use safer, non-toxic and renewable materials. So this reduce the hazards waste generations, uh, and minimize the risk to workers and the environment also. So the industries such as the paramedical industries, then polymers, and that material engineering are increasingly adopting the green chemistry principles. So these technologies, it show that it's show how the engineers involved play a direct role in reducing the waste and supporting sustainable manufacturing. Then role of automation and the IT. How the automation and IoT, yes, Internet of Things, support a zero waste manufacturing. So the modern industries are moving towards intelligence, connected, that self-optimizing system, right? So this shift play a huge role in waste reduction. First one is smart factories. Smart factories use the integrated automations, robotics, and real-time data to run the operations with minimal human errors, right? So because machines and system communicate with each other, the entire production line become more efficient. So this reduce the defects, downtime, overproduction, and energy waste, so all of which contribute directly to zero waste goal. Then sensor based tracking. IoT sensor monitor the temperature, vibrations, machine's performance, material flow, as well as that energy usage also. So this real-time data help the detect abnormal, anything happen in our abnormal, we can easily to find out earlier. So for example, excessive, yes, vibrations that may lead to a machine's fault or a material loss. So by identifying issues immediately, the industries can prevent waste before it happens. So another one is predictive maintenance. Traditionally, the machines are repaired only after they fail, so which leads to breakdown, defects and delay. So with IoT and AI, factories use the predictive maintenance where sensor predict failure before they occur. So this avoids machines downtime, that it's reduced the spare parts wastage. So the resulting is improve the reliability as well as cost savings. Then digital twins for process optimizations. The digital twins is that it's a virtual replica of a machine, system or entire factory. So the engineers can stimulate different scenario, test improvements and identify the potential bottlenecks, so without stopping real operations. So this ensure optimized process reduce the that uh, trial and error waste and better decision making. So the automation and IoT together create the smarter, yes, more efficient in the factories. As a future engineers, you will play a key role in the building these technologies, advanced manufacturing ecosystems. Then circular economy in manufacturing. How the circular economy, it's connect with zero waste manufacturing. The circular economy is all about keeping the material in use for as long as possible, extracting maximum value for them, the minimizing the waste at every stage. First one is its recycling loops. In circular system, the material are not thrown away, they circulate. Yes, the manufacturing design process where material, plastics, chemicals and other materials are continuously recovered, recycled and reused. For example, you take aluminium scrap from machinery can be melted and reused repeatedly without losing quality. So these recycling loops are essential for conserving resources and reduce the environmental impact. Then product life cycle extension. Instead of designing product with short life span, the companies now focused on making them last longer. So this can be done longer. This can, it's a durable materials, easy repairability, then upgrade components, even the modular design. So when the products stay in use longer, industries it's produce less wastage as well as consume fewer raw materials. So as a engineers, your design directly influence how long a product can remain in service. Then remanufacturing. Remanufacturing means it's taking used or worn out product and restoring them to like new condition. Instead of manufacturing a whole new product, the industries reuse the core components and replace only what necessary. So the automotive, that automatic automotive industries, aerospace industries, even electronics, even the heavy machinery industries also rely on remanufacturing to cut cost, the reduce wastage. So this process not only save the material but also reduce the energy consumption compared the that's it's producing new items. Then overall the circular economy helps industries shift from a take, make, dispose. Yes, circular economy major formula is take, make, dispose. So the model to a continuous regenerative systems. Yes, and engineers play a central role in designing for reuse, recycling, and long term sustainability. How we can change the formula. Yes, previously you know that take, make, dispose. In that formula, the circular economy entirely helpful for rechanging this formula. Instead of how we can reuse, how we can recycling, and long term sustainability. That formula is most important in their modern industry. That formula is introduced in the circular economy to replace the traditional economy, I mean the formula of take, make, dispose. Then zero waste design, which how the zero waste design, which focus on designing product in a way that minimize the waste right from the beginning. So the first one is eco design. Eco design is a sustainable approach where environmental impact is considered during the product entire life cycle, from raw material to manufacturing, usages, and disposable. So this goal is reduce the uh, pollutions, resource consumption, energy usage, and end of life wastage. So example include designing electronics that use fewer toxic material, or creating shape that minimize cutting the waste in manufacturing. Second, the modular product. A modular product is made up of easy to replace or easy to upgrade components. This approach helps reduce the waste because product lasts longer, then only the faulty parts need replacement, then upgrading becomes simple without discarding the whole product. So the industries like electronics, furnitures, or automobile, yes, they increasingly use modular design for sustainability and cost savings. Then sustainable material selections. Choosing the right material play a huge role in zero waste outcomes. So the engineer aim to materials that are recyclable, biodegradable, then renewable, non-taxes, durable, everything we want to be considered. For instance, using recycled aluminium instead of virgin aluminium, right? So are opting for biodegradable polymers over conventional plastics. So the material selection also consider the carbon footprint and ease of recovery after the production's life ends. So the zero waste design ensure that sustainability is embedded, that from the first sketch of the product. So as a future engineers, your design, right, the decisions can significantly produce the, yes, the waste throughout the entire manufacturing chain. Here I am just giving one live example. Toyota. Yes, let's look at the real world example of zero waste principle in actions. One of the most famous pioneers of lean manufacturing, right? The Toyota's entire production system is built on minimizing the waste and maximizing the value. So one of their core achievement in the integrations of lean tools such as ingest, just in time and Kaizen. So which drastically reduce the unnecessary steps and improve the process efficiency. So the lean manufacturing, Toyota it's developed the Toyota production systems which later become the foundation for global lean manufacturing. Their process focus on eliminating the 7 type of waste. Muda. Previously we discussed na overproductions, waiting, transportations, motion, inventory, right? Defects, the 7, yes, the types of Japanese concept. So making workflow smooth, uninterrupted and highly efficient. So this system has inspired almost every modern manufacturing company. Then zero defects. This company aims for near zero defects by embracing the quality at every stage. The operations are trained to stop the production line if they notice even a small abnormality. This prevent defective benches and avoid the that it's rework also. So defective badge patches, everything should be avoid for reworks. By catching, it's catching errors early, the Toyota saves times, material and cost while improving the customer satisfactions. Then reduce the scrap metal also through continuous improvement, that is the Kaizen methods they followed. So the Toyota has optimized machining, stamping and assembly process to reduce the scrap material significantly. So the better cutting patterns improve, it's a part design, and previous machines help them use material more efficiently. So this is one of the reasons why Toyota is considered in the global benchmark for sustainable and efficient manufacturing. In this case, clearly shows how the engineering, smart process and a culture of improvement can lead to significantly waste reductions. As a future engineers, this system can inspire you to design, yes, clear, efficient and more smarter manufacturing environment. Next, Tata Steel and Mahindra. Yes, the industry leaders, how the Indian industry leaders like Tata Steel and Mahindra are successfully applying the zero waste and circular economy principle. Both the companies are known for integrity, sustainability into their engineering and manufacturing process. Slag recycling. The Tata Steel is one of the global leader for slag utilization. That is, instead of sending steel slag to landfills, they process it and convert into the valuable material used to, that is cement manufacturing, road and railway, uh, ballast, then constructions, aggregates. So this is not only reducing the waste but also replace the natural resources like stone and sand also. So the Mahindra has followed the similar circular practices in the foundry and metal operations, ensuring the minimal waste output. Then energy recovery. Both Tata Steel and Mahindra use the advanced technologies to recover the energy from their operations. For example, Tata Steel, it's capture waste heat from blast, that in convert it into the electricity through waste heat recovery boilers. So the Mahindra, it's a automotive plants uses heat recovery systems and solar energy integrations to cut energy consumptions. So this reduces carbon emissions and lower operations cost. Then closed loop water systems. Water conversations, conservation, that is a major priority. The Tata Steel has created closer loop water recycling systems where processed water is treated and reused repeatedly, so the reducing fresh water withdrawal. So the Mahindra has implemented similar system in its automotive plants, where that water used in painting, cooling and cleaning is treated and circulated back into the process. Then these closed loop systems are crucial for sustainability in water stress regions. So that together these practices demonstrate how the major Indian companies are moving towards zero waste circularity and uh, reduce the efficient engineering. They serve as strong models for future engineers like you, who will be shape the next generation and sustainable industries. But some of the challenges is behind for implementing the zero waste manufacturing. Before concluding, it is important to that it's understand that achieving the zero waste manufacturing is not always easy, but industries face some several challenges while it's trying to shift from a traditional system to sustainable one. First one is high initial cost. Many zero waste, that technologies like automation, IoT sensor, waste treatment plants, or energy efficient machines require significant upfront investment. So, although these investments save money in the long run, the initial cost can be barriers, especially for small and medium enterprises. Second, the technology requirements. Zero waste manufacturing relies heavily on advanced technologies such as digital monitoring, that it's a green chemistry and recycling systems. The industry must upgrade their existing equipments and process to adopt these technologies effectively. Then workforce training also. Even the best system will fail if people not trained to use them. So the employees must learn new methods, new tools and new way of working. So from learning practice to digital tracking. So this require time, efforts and continuous upskilling. That is also the medium and small scale industries is not easily possible to train that their employees for upgrading their skills or to appoint some new skill employees, right? Then resistance to change. The human resistance is one of the biggest challenges. The workers and managers who are used to old methods may hesitate to adopt the new process, especially if they involve technologies or process modifications. So overcoming these required awareness, the leadership support and the strong culture of continuous improvement. These challenges show that zero waste manufacturing is not just a technical shift. It is also on organizational and cultural transformation, but the right approach, the industries can overcome these barriers and move towards over sustainable and efficient systems. But whatever may be, finally, let's look at the key benefits of adopting zero waste manufacturing. These outcomes shows why industries around the world are moving towards sustainable and engineering practices. First, cost savings. By reducing the scrap, energy waste, defects, yes, or and unnecessary process, the companies save huge amount of money. Of course, I agree that the first initial investment is high, but one time investment, it's make the continuous save cost methods. Right? So the lower material usage, reduce the disposal cost and improve the process efficiency, all contribute the long-term financial gain. So even though the initial investment may be high, the return on investment is very strong. ROI is very strong in that concept. Then reduce the emissions. Zero waste practices, it's help the industries cut down on, it's greenhouse gases, air pollutants, that wastewater discharge and solid waste generations. So the cleaner process mean a smaller carbon footprint and healthier environment around industry area. This is especially important for sectors like steel, chemicals, even energy. Then better resource efficiency. Industries use the resources like metal, minerals, energy, water much more efficiency. This reduce the dependency on raw material and help the conserve natural resources for the future. So the efficient process also mean higher productivity and it's better quality products. Then sustainability compliance. Government and international bodies now require industries to follow strict environmental and sustainability standards. Zero waste approaches, it's help the companies to meet ISO standards, environment regulations, even CSR commitments also, corporate social responsibility commitment also. So this improve corporate reputations and avoid the legal penalties. So overall, these benefits shows that zero waste manufacturing, it's not just for good for the environment, right? It is also good for business and essential for the future of engineering. Then finally we can discuss about what is the future trends in zero waste manufacturing, that is scope of zero waste manufacturing. As we look ahead, the several exciting trends are shaping the future of zero waste manufacturing. These trends combine advanced technology, automations, and sustainability to create smarter and greener industries. First one is AI driven optimization. The artificial intelligence is becoming a major force in manufacturing. You know very well about that. So the AI algorithms can analyze the huge amount of data from machines and sensor to optimize. Example, material usage, energy consumption, product scheduling, quality control. So AI help the protect the defects before they occur, so reduce the scrap and improve the process efficiency, all essential of zero waste manufacturing. Then robotics in waste sorting. The industrial robots are now being used to automated waste sorting. So, especially in recycling plants and large manufacturing units. With computer visions, robots can identify, pick, and separate material faster than more accuracy and humans. Then this improve recycling efficiency and ensure that more materials re-enter the production cycle instead of becoming waste. Then carbon natural factory, neutral, yes, factories. That is, the industries are moving towards carbon neutral or even carbon negative factories. It's include renewable energy integrations, like solar, wind, biomass, then carbon capture technologies, net zero emissions strategies. So these factories aim to eliminate the carbon emissions while producing the minimal waste and creating the cleaner future in industrial operations. So the future of manufacturing will be highly automated, data driven, and sustainable. Then finally we come to conclusions. That remember that zero waste manufacturing, it's not just the environmental concept, it is the necessity of engineering. Then it help the industries reduce the waste, improve efficiency, as well as it is the more important, stay the competitive in the world. Okay, then zero waste approaching are both sustainable as well as cost effective. Companies save money by reducing the scrap, lowering that energy usage, and minimizing their defects, right, all while protecting the environment and improving their operational performance. Then, zero waste manufacturing required future ready engineering skills. The technology like AI, IoT, automotive, automations, digital twins, advanced material are transforming how the modern factories operate. So as upcoming engineers, your ability to design efficient process, apply sustainable principles, and innovate with new technologies will be crucial for building the factories of the future. So I hope this section inspired you to think differently about how engineering can shape a clear and smarter world. Right? This time it's open forum for you. If any queries, please. Queries or something, some discussions, please, this is the time to encourage you. It's okay. In one question, right? In normally our mind asks the questions, who is responsible for zero waste manufacturing in the company, right? Usually, who takes the lead, right? Every company is having lot of department is there. Actually, who is responsible for leading that concept? In company, zero waste manufacturing is not the responsibility of one single person. It's required multiple role working together. However, the specific positions have primary responsibility. Operations are production managers. Ensure the manufacturing process, minimize the waste. Implement the lean efficient practice. Environmental health and safety manager, EHS. It's lead the sustainability and waste management initiative. Sustainability and ESG manager. That is, yes, environmental sustainability department, that is design zero waste strategy and long-term sustainability goal, correct? Then quality managers ensure defect-free productions, reducing the rework and scrap. Then supply chain or product procurement manager, that is select eco-friendly suppliers and materials. Then maintenance team optimize the machines to reduce the resource consumption and losses. Then top management, CEOs, secretaries, that is also, they are also responsibility because provide approval, budget, policies and organization support you. So zero waste manufacturing is a sure, it's a shared responsibility. We can't say like that it is the one department responsibility, but normally yes, EHS, environmental health safety manager and production manager usually take the lead of any company regarding their zero waste manufacturing concept. I hope that it's very clear to all. Yes, if you having any doubt, please ask me, otherwise to leave the sessions. Thank you.
Thank you, ma'am.
You, ma'am.
Yes.
Thank you, ma'am.
Thank you, ma'am.